Now we want to see how to use substitution and elimination on nonlinear systems. Here we have one equation that is a linear equation, no exponents. However, the other one is not. So what we're going to do is the substitution method, like it says in the instructions. And here's how we do that. The either equation that we're going to solve for one of the variables. Now we can actually do that in either of these two equations, so it's not really going to matter which one we choose. I'll take the top one and solve for y, because that seems like a very easy process. If we subtract x squared from both sides, we'd have y equals 6 minus x squared. And then, of course, the technique of substitution says we want to use the other equation, and in place of the y, we want to substitute the 6 minus x squared. And so there's an equation for us to solve now. So getting rid of the parentheses by distributing the minus sign, we can then add 4 to both sides. We'll put things in a little bit more standard order. So the x squared we will put first, then the x, and then of course negative 6 plus 4 is negative 2. And so now we will solve that equation. We've had pretty good luck with factoring, so we will give that a try. Two things that multiply to give a 2 and subtract to give 1 would be 2 and 1. Opposite signs, positive on the larger. Set each of those equal to 0 and finish solving. Now once we get the x's, we can take each of those and substitute in any equation whatsoever up here to get the y's that go with them. For example, if we take this equation and use x equals negative 2, we'd have 6 minus negative 2 squared. Well, the negative 2 in parentheses squared is positive 4, and 6 minus 4 is 2. And y equals 6 minus 1 squared. 6 minus 1 is 5. Now to write these in the proper format, we would have the negative 2, comma 2 in parentheses, and the 1, comma 5 in parentheses. So this is what our answer should look like. Now, although we could use the same technique on this one, I do want to show you how the elimination works. This one is not a complete example because, as you can see, we have x squareds that are already lined up vertically and y squareds. In the previous problem we had an x squared, but we only had an x squared in the top equation. So this one has x squareds in both, has y squareds in both. However, we will do the same thing with this that we did before, the elimination method. We need to get the coefficients of one of the two variables to match. Now, when we talk about variables, we mean the x squared or the y squared. In order for the y's to match, we need the top to be -4. So we're going to multiply through by -4 on the top. That would make a -4x squared minus 4y squared and minus 36. We will copy down the bottom one and add -4x squared and 9x squared is a 5x squared. The y squareds are going to subtract out. Now -36 plus 36 is 0. Now don't confuse this with what we learned in the first section. This is not some constant equals 0. We can finish solving by dividing both sides by 5 and doing the square root of both sides. And so x is equal to 0. Now, according to the first equation, x squared plus y squared is equal to 9. And if x is a 0, then we have y squared equals 9. When we do the square root of both sides with the plus and minus, we get y equals 3, and also y equals -3. Square root of 9 and negative square root of 9. So then our answer would go like this. We'd have a 0, 3, and a 0, -3.